morning, ladies and gentlemen. Good afternoon, good evening, wherever you guys are. I hope that you're all doing okay today. I hope that you can all hear me and see everything so far. So we're going to go ahead and get started, and as people join in, they can just kind of hop in with us. So again, good morning, good afternoon, good evening, ladies and gentlemen, wherever you guys all are. I hope that you're all doing as well as you can be, considering the circumstances of life right now. So my name is Jillian Kreider, and I am the TOS sales specialist here at RIEGL USA. I'm also the lady up in that picture up on the screen at the moment. So I would like to welcome you all to today's webinar, which is LiDAR for vertical construction, applications, and real-world examples. So we're going to have some time for questions and answers at the end of the session today. So please, if you have any questions, send them in during the session today. And if I can't get to your question during the session, don't fret. I'll get back with you guys via email. So we're actually going to go ahead and start today by asking you guys a quick question, which is, are you using LiDAR for construction now? Yes, no, or I would like to. So we're going to give you guys a few minutes just to see what our answer is. Wow, thank you guys so much for voting. This is a really nice little turnout. So I'm going to give you guys about 10 more seconds. You guys are pretty evenly split between the three, which is nice to see. So we've got a good chunk for yes, a good chunk for no, and definitely some that would like to. So we're going to go ahead and close, and we'll go get started. So I'm going to run you guys through our agenda today just really quickly and what we're going to be covering during our time together. The first will be, why do we use LiDAR for construction and benefits we can see of using construction for construction. We will then discuss different construction applications with terrestrial LiDAR, such as QAQC, verification, BIM, monitoring, and drainage surveys. From there, we will go into some real-world examples showcasing our personal scanning project that we are undertaking at our new RIEGL USA North America headquarters, as well as two projects that were generously provided to us for this webinar by one of our users, GeoPoint Surveying. And after that, we'll wrap up with a Q&A. So why would we want to use LiDAR for construction? One of the largest reasons is safety. Using LiDAR on a construction site is a cost-effective and complete way of improving your construction project safety through the improvement of your efficiency on site. If you don't have efficient processes, it can be hard to maintain the level of safety needed on a project, and a lack of safety is going to kill any efficiency that you may have had on site. During the construction process, scans can be used to identify potential safety issues and thusly improve your construction safety. LiDAR scans are inherently safer than manual inspections, and even dangerous high-risk areas can be scanned with LiDAR and reviewed away from the site. So savings. Time is money when you are out on the job site. Going over time and going over budget is bad for the bottom line, both for you and for your end client. Utilizing LiDAR on the job site allows you to lessen your time and manpower in the field, saving you money instantly and reducing the need for additional staff on site. Monitoring. So this to me is one of my favorite reasons of why you would want to use LiDAR for construction. You can build a plan from the very beginning to capture your set milestones in your job site's progress. So you can have a piece of land that just holds so much potential, and you can visualize using LiDAR at every step of the way until you're finished building. LiDAR gives us that instant and accurate 3D visual comparison between your anticipated planned progress and the actual progress on your job site. So then with LiDAR, with quality control from start to finish, LiDAR can permanently document and keep records of your job site from pre-land clearing all the way up through your finished product. Being able to revisit the job site on any day that you've scanned at any given time will allow both your team and your client to have confidence in the work that's being done. Basically, LiDAR allows us to measure, quantify, visualize, and monument our projects in a quick, concise, and efficient manner. So LiDAR can benefit construction projects clearly in a multitude of ways. You can deliver your accurate surveys quickly through every construction phase. You can provide information for simulation and analysis when developing your project. You can identify maintenance and repair requirements on the project as needed in real time. ensure that your project's staying on target, identify potential safety issues, and track your building projects and produce digital twins for BIM applications as you go. So this increases your productivity, reduces your survey costs and errors, and allows for real near-time information for quick decision-making. With this, we're essentially allowing ourselves to create as-built of projects, validating the current conditions so that we can effectively and efficiently conduct our pre-work. We can model our data so subcontractors can prefabricate pipe, conduit, and ductwork to speed up field production. We can solve problems that may have been unforeseen until we did the scans and correct incorrect as-built data. We can take measurements of a building in fractions of a time, quantifying and delivering it to the team in days, sometimes even hours, and essentially predict the future in concrete. Because of this, we can then deliver accurate 3D data to owners, subcontractors, and team members quickly and efficiently, enabling the team to make better and more informed decisions in a shorter time frame. So let's jump right into some of the applications. Here we have an example of QAQC for a tilt panel pour. The goal here with using LiDAR was to analyze the layout of these tilt panels before the pour to quality check the embeds, blockouts, and sleeves to ensure they were in the correct location. This data was provided to the team at 2 a.m. before a 4 a.m. pour, and a critical adjustment was able to be made in the field prior to the pour. As you guys can see in the bottom right screenshot, there was an area that required a double-side embed that showed as such in the model that was only one-sided in the field. This adjustment, being able to be made on the fly, potentially saved the team roughly $10,000 per panel to re-pour, not to mention the 8-day curing time for each panel and crane remobilization. This panel by panel analysis, actually that was able to be done within 8 hours of the scan completion, thanks to LiDAR, saved the company from a delay in schedule and quite a bit of money. Verification. So here's an example of how verification can be done on your site with LiDAR. This is a completed project that had been turned over to the owner who was having water pooling issues on their site. What was found was that at the turnover of the project, 2 of the locations on the site had improper drainage and were suffering from severe ponding. Both terrestrial LiDAR and drone imagery were utilized on this site and helped to paint a clear picture for both the owner and subcontractor of where the high and low lying spots were near the drainage areas. Because of this data and the clear need of the owner, the subcontractor has now since been able to install an updated drainage system to help alleviate this issue. So the drainage map. This is an example of a drainage map captured with LiDAR showing high and low lying areas in reflectance view. Water management is a big deal. Speaking as a Floridian, I can definitely attest to that one. Whenever we have really big rains, whether it be from normal storms, flash floods, or hurricanes, we need to know where the water is going to go on our site, and the ability to create a drainage map from our LiDAR data shows us exactly where it's going to end up. This slide here shows an example of how LiDAR can be used for BIM applications. This project in particular had the architect and project team asking for the data for the interior build-outs. The LiDAR data helped capture that overhead utility data in existing conditions on the site, and then the resulting information and analysis was provided to the architect and project team. This helped to save them hours of modeling and as-built time, and it also established a baseline for future design. The digital twin that was created actually also helped to calculate fill that completed concrete in the admin facility, or the admin room of the facility, which was a contractor error that had been occurred previously. Monitoring examples. So this monitoring example here shows a building that's currently under construction going up to a building that's already been completed. What the company is doing here as a monitoring project is measuring the distance between the buildings to ensure that the building that's currently going up remains perfectly plumb. Using the known factor of the completed building, knowing that it's perfectly plumb and level, helps to establish a baseline for the company to work off of and ensures that their building that is under construction is staying within their specifications. So to jump into some real world examples, I would like to talk to you guys briefly about the LiDAR for Construction project that RIEGL USA is personally undertaking. So myself and a few colleagues are currently conducting regular monitoring scans of the new RIEGL USA North America headquarters, which is under construction presently in Winter Garden, Florida. We go out weekly, if not more often, to collect scans of the facility at different milestones in our project timeline. Not only is it extraordinary to get to see our facility being built in real time, it's a personal joy of mine to get to work hands-on in the field and learn more about how our LiDAR solutions really truly benefit the construction industry. So some points of interest that I've conducted in my scans so far include our land clearing, the elevator shaft construction, our server rooms construction, prep and pour for our concrete, prep and pour for our tilt walls, and then our steel beam and joist placement. So I'm just going to run you guys through some pictures and some screenshots really quick of some of the different milestones that we've done thus far. So this picture right here shows you guys the concrete footer of our building. This was after its pour and during its set. This was before our concrete slab got poured, so you guys can definitely see that the ground was on the move. And then this is a data screenshot that was actually captured the day of that same image that we took. So again, concrete footer before the concrete slab pour the next week. So again, why are we using LiDAR for construction, let alone on our own construction site? This example right here is one of the reasons why. What you guys are looking at here is a line drawing of our concrete footer and slab before the anchor bolts were set in place. Our construction company has their own BZ400i terrestrial laser scanner, and they went to scan the site for verification that the anchor bolts were going to go where they needed to go. What they found, however, was that the anchor bolts circled in red here were off by a few inches, but that the one that just popped circled in red right now was off by a few feet and did not align with the CAD drawing. They found this by comparing the point cloud model that they captured that day to the CAD model that was already established. By finding this out, the field crew was able to adjust it immediately and anchor bolts were set in their proper place. This saved them the headache and the hassle of having to go back down the line in the project to have to do a major tear out and redo the anchor bolts, since this is such a fundamental part of the building and would have delayed the entire project. So just for a few more images, this is of our elevator shaft under construction and the concrete slab poured. This next one is the concrete slab after it had been poured and while it was curing. And so then this is actually an image of the current state of the North America headquarters where the steel beams and joists are now going up and being welded. So the site is highly active. So our weekly scans have definitely become more of a necessity to make sure that we're capturing the development of our headquarters literally from the ground up. So you guys can see some data from the project thus far. This is a screenshot from May 15th. This is in reflectance view. As you guys can see, this is the entire job site, as well as the progress that has been done, even just from a few slides back with the concrete footer and the slab. We've actually moved on quite a bit in our project timeline from that concrete footer, as you guys can see here. So here's that same screenshot in an Xray view. So for any of you guys who are already using the RIEGL software with RiScan Pro, the Xray view is one of our newer views that you can use. We definitely like it around here. So with this Xray view, this actually helps to show the steel beams and the joists a little more clearly on the site, as well as the positioning of our scans. So our next two real-world examples have been generously provided to us today by one of our users here in the United States, GeoPoint Surveying. So GeoPoint is dedicated to the close interaction, open communication, and shared goals with a philosophy of producing when called upon as being the benchmark of their success. As you guys can see here on the slide, they have offices all throughout the state of Florida, and if you'd like them to contact them directly, I have the contact details for Matt Roberts here on the slide. I would personally like to thank GeoPoint and Matt for providing us with these two real-world examples of how to use LiDAR for construction, so let's get into them. So this is Block C in downtown Tampa, Florida. So GeoPoint went out and they scanned this structure with their VZ2000i scanner. This survey was conducted to confirm the column dimensions at a specified elevation to ensure the structural integrity of this building. A total of 17 scans were utilized to create this model, and it took them 2 days from scan day to their final deliverable, which is really quite impressive. The ability for them to safely and accurately do this job was one of the major benefits to using terrestrial LiDAR data in a high construction zone. The Entryway Fountains in Pasco County. So GeoPoint was first called out to this site to determine the shift that was happening as the retainer walls were settling. You guys can see the slight discrepancies between the two sides, but again, overlays show everything. So they scanned every Friday for 4 weeks straight to come up with the complete data set, which displayed the gradual shift in the walls settling. Once the construction of the fountains were complete, GeoPoint was then called back in to survey the site for a construction as-built package submittal for Pasco County. The benefit for them scanning this project was the ability to come back for more data should they ever need it in the future. So I'm actually going to launch my next poll. Before we get into the Q&A, we're going to launch our next poll. So this one is going to be, what topics would you guys like to see covered in future webinars? So we have an overview of RIEGL TLS LiDAR. We have TLS LiDAR in surveying, kind of the whole gamut. This is my contact information. So again, I'm Jillian Kreider. I'm the TLS sales specialist here at RIEGL USA. My email address is jkreider@realusa.com, and that's the office phone number. So I would like to thank you guys for joining me today for this webinar. I am terribly sorry about the questions, but please go ahead and send me an email. I will answer them as soon as I get them in. And I really appreciate you guys joining me today. Have a great day.